All right, let's dive right into a cosmic detective story. See, our home galaxy, the Milky Way, it's not just floating around randomly. It's on a mission. It's being pulled and it's being pushed by these enormous, invisible forces. It's a real cosmic tug of war.
And that's the big question, right? I mean, think about it. What could possibly be strong enough to grab an entire galaxy? We're talking hundreds of billions of stars, planets, the whole shebang, and yank it in one specific direction. That's the mystery we're going to solve today.
Get this is the speed of our galaxy's mysterious motion. We're hurtling through space at a staggering 627 kilometers per second. That's over 1.4 million miles per hour. And this isn't just random speed, it's measured against the most fundamental backdrop there is, the faint afterglow of the Big Bang itself.
Now, to be clear, this isn't just the universe expanding and carrying us along for the ride. That's happening, sure. But this is something extra. It's what astronomers call a peculiar velocity. It's like we're not just on a raft floating down the river. Our raft has a rocket engine strapped to it, pointing us toward one very specific spot in the sky. So you can imagine for decades, this had astronomers completely stumped. It was a huge clue that something massive, something with just an unbelievable amount of gravity, had to be out there, tugging on us from across the void. The hunt was on.
Okay, so every good whodunit needs a prime suspect. And in this story, the first one on the list had a fantastic dramatic name, the Great Attractor. The evidence for this thing started piling up back in the 70s and 80s. First, scientists clocked our incredible speed. Then, a team, get this, they were nicknamed the Seven Samurai. They found out we weren't alone. Whole clusters of galaxies were all streaming in the same direction like a massive river in space. By 1988, they had their culprit. The theory was pretty simple. Somewhere out there, hidden behind the bright lights and dust of our own galaxy, was a single, colossal concentration of mass. A kind of giant, invisible gravitational magnet that was pulling everything in our corner of the universe towards it. That was the Great Attractor. And you knew there was a but coming, right? When astronomers finally managed to map out the mass in that region, the numbers just didn't add up. The Great Attractor was real, for sure, but it wasn't nearly powerful enough to explain our crazy speed. It wasn't the lone culprit. The case was far from closed. This meant the investigation had to zoom out, way out. Scientists realized they weren't looking for a neighborhood bully. They needed to find the biggest player on the entire cosmic block, something lurking way, way beyond the original suspect. And to get what they found, you really have to understand our cosmic address. So let's start here, at home, in our own Milky Way galaxy, which is part of a little galactic cul-de-sac, a small cluster of galaxies gravitationally tied together. That's our immediate neighborhood, the local group. But even our little group is just a tiny suburb way out on the edge of this vast celestial metropolis called the Laniakea supercluster, a structure made of thousands upon thousands of galaxies. And here is the kicker. That entire structure, Laniakea and everything in it, including us, is being pulled towards something even bigger, an absolutely immense congregation of galaxies known as the Shapley supercluster. This is the real heavyweight. And when I say heavyweight, I am not kidding. This thing is an absolute monster. It's got the mass of 50 quadrillion suns. Let that sink in for a second. It's one of the most massive things we've ever found in the universe, and it's pulling on our entire cosmic neighborhood with incredible force. But here's the final plot twist, and it's a wild one. Even the unbelievable gravity of the Shapley supercluster isn't enough to explain our full speed. The math still doesn't quite work. There's another force at play here, because it turns out this story isn't just about what's pulling us. This is where it gets really weird. It turns out our galaxy isn't just being pulled, it's also being pushed. I know, that sounds totally impossible, right? How can you be pushed by nothing? How can a big patch of emptiness exert any force at all? Well, the answer is in another giant structure, or more accurately, the lack of one. On the complete opposite side of the sky from the Shapley supercluster, astronomers found this huge, unusually empty area of space, a cosmic void. They named it the dipole repeller. Okay, here's how it works. Imagine our galaxy is sitting in space, and it's surrounded by stuff.
galaxies, dark matter, all pulling on us pretty much equally from all directions. Now, what if you took a giant cosmic ice cream scoop and removed a huge chunk of that stuff from one side? Well, that's the dipole repeller. All of a sudden, the gravitational pull from that direction is gone. But the pull from the opposite side, from the Shapley supercluster, is still there, stronger than ever. So the net effect feels exactly like we're being pushed away from the empty spot.
So there you have it. The final verdict is in. It's not one single force, it's two. We are caught right in the middle of a cosmic tug of war.
On one side, you have the incredible gravitational pull from the Shapley supercluster, reeling us in. And on the other side, you've got the effective push from the vast emptiness of the dipole repeller, shoving us away from it. And those two forces, working together, finally explain our galaxy's mysterious high-speed journey. And this isn't just a fun theory anymore. This is really the scientific consensus. The old idea of one simple great attractor just doesn't hold up. As one paper puts it pretty clearly, no single attractor can explain what's happening. The reality is this incredible dynamic dance. So the big takeaway here is that our galaxy's path, our journey through the cosmos, isn't random at all. It's this beautiful, delicate dance choreographed by the biggest structures in the entire known universe. It's just amazing to think that we're on this epic journey, caught between the gravity of a cosmic titan and the emptiness of a vast void. This dance is far from over, and it leaves you with this one truly awe-inspiring thought. Where will this cosmic tug of war take us next?